Okay, so if we look at number 5, it has a GCF to start with. Can you guys see what the GCF is?
2.
Yeah, so 2 and 250, so they're both even numbers. We can take 2 out. So I'll take the 2 out, and then that leaves me with x to the third minus 125. And so this is actually a difference of cubes. So that's a perfect cube, x to the third. And then 125 is a perfect cube also. It's something to the third power. 5 to the third power. Okay, so we've got 2, and we've got x to the third power minus 5 to the third power. So we've got a little parentheses and then like a big parentheses. And we have to remember SOAP. So we're going to do the same sign, the opposite sign, and then always positive. You guys remember that? Sound familiar? So same sign, opposite sign, always positive. And then we started off with this one, right? And we did, remember we did 2 colors. And we'd start off with this one, and we'd say, okay, in the first parenthesis it happens once. And then in the second parenthesis we do 2, x times x, and x times something. And then we switch colors. I'll switch to my black pen. And then we do 5. So 5, does that look any different? Yeah, it's good, you can tell. And then 5, and then 5 times 5. You guys remember that? Okay. And this is very similar to number 6. You guys see how it's similar to 6? So this is difference of cubes. 6 is the sum of cubes, and it doesn't have a GCF. Okay. So we've got the 2 in the front. We got x minus 5. And then we've got x times x, so that's x squared. And then x times 5 is 5x. And then 5 times 5 is 25.
So it says that these are, I feel like I definitely turned those in.
So find the transformations first. Can you tell what the transformations are? You think you have them? Okay, what are they?
Vertex is 4, 3.
Okay.
Vertical stretch of -2.
Vertical stretch of regular 2. The negative is something else. Do you know what the negative is?
It's reflected over the x.
Yep, reflected over the x. Okay, so it's so that the negative makes it go upside down. Okay, reflect over x, vertical stretch of 2, and then what else?
Right forward.
Mm-hmm. Okay, perfect. Okay, so we did transformations, we did vertex. We got to graph it. Do you guys want to do the part where you graph it by hand, or do you want to just graph it on the calculator?
Preferably by hand, but it also would probably be nice to not do it on the calculator.
Okay.
Can we do one at hand and one at calculator?
Sure.
Yeah.
Okay. Which way do you want to do? This one would be harder to do by hand because it has more transformations, so maybe we should do this one by hand. And we could do 17 in the calculator real quick since...
17's like cross out.
Yeah, but since we don't have to do it, we could just graph it real quick and call it good. Yeah, okay. So what are the points?
It's -2 for -1, 1, 0, 0, 1, 1, 2, 4, right?
Mm-hmm. Okay. So, and I'm leaving that up on the board. It works the same for quadratics. So the same stuff that I've written under, like the a is just multiplied by the y. And you do that first. and then the x and the k, or the h and the k, that those are added and subtracted to the x and added and subtracted to the y, and you do those next. That is the same for a quadratic. So the number in the front is multiplied, and it happens to the y. So we're going to take all the y coordinates, and we're going to multiply them by -2.
That's why I got it earlier.
Mm-hmm. Good. So that was us doing the stretch and the reflection. That's what we were doing.
Oh, sorry. So I wrote vertical stretch -2,
Mm-hmm.
and that did the exact same thing as writing down vertical stretch 2 and reflecting for x.
Mm-hmm.
Could I just write reflecting or vertical stretch -2? Or would that just not work?
It wouldn't work for it would work as far as like what you do to the points, but it wouldn't work as far as being an accurate transformation.
So if I were to run the test, I'd be wrong.
If you wrote it as the answer for a transformation, it would be wrong. But if you were using that to help you write the points to graph it, it would be fine.
Okay.
Yeah.
Could you think of like a vertical stretch or vertical compression as like a stretch as like making it like longer and like a compression like flattening?
Yeah.
Because that's really what tripped me up on like,
Mhm.
the first quiz.
Yeah.
It's
Yeah.
on number 3, I think it was.
Mm-hmm.
Like it was vertical compression, but it made it like a vertical stretch. So.
Mm-hmm. Yeah. Yes. Yeah. Vertical stretch makes it tall and skinny. Compression makes it short and fat. Mm-hmm. Okay. What should we do to the points next?
Try this.
Mm-hmm.
So, like,
So if we go right for, does it happen in the x coordinate or the y coordinate?
The X group.
X coordinate. Okay. And what are we going to do to the x coordinate? Add 4.
I had this all right earlier,
Good.
but I erased it because you said
Oh, because the name of the transformation was wrong.
Yeah.
Yeah.
Does this include shading?
If you look at the symbol, it'll tell you. So in between we have an equal sign.
So it's not.
So it's not shaded. Yeah, this would just be just a straight line, solid line, no shading. Yeah. Okay. And then for the y value, what do we have to do? Add 3 to go up 3. Mm-hmm. So what's the domain? How far does it go to the right and left? So we can see the left has an arrow, the right has an arrow. Mm-hmm.
0.
So if it went to 0, it would stop right here.
Oh, negative 3,
Negative infinity to, now this is a right arrow. I'm not worried about it going down. Yeah, so it went to the right, so it's positive infinity. Okay. And then for the range,
That's from the highest to the lowest.
but we always write the lowest first. So we're going to say it went down forever,
So negative infinity to 3.
and then up to 3.
Oh, so just be a y coordinate.
Just the y coordinate, yeah. And then at the 3 is that point's actually on the graph, gets a bracket. Okay?
Do you think, like, if you're cool with it, can we move on to like 18 or 19?
Yep.
And increasing in like the end behaviors.
Yeah. Well, on these ones, we're going to have to do increasing. We were about to do increasing and decreasing, and we had end behavior too.
Oh.
So we did domain range, got increasing, decreasing. So go ahead and just sketch the picture over here.
Is this for the, oh, no, never mind.
So if my stick figure starts walking, which way is he walking?
Up.
Uphill, so that's increasing. He gets to the top, hits the vertex, and then what does he do?
Goes down.
Decrease, okay. And we have to write the x value for a left arrow, the x value for the vertex, and the x value for a right arrow. So what's the x values for the arrows?
Negative infinity and infinity.
Okay, so left arrow, right arrow. And then what's the x value for the vertex? 4. Okay. So for the increasing interval, we're going to say,
It'd be negative infinity to 4.
okay. And then at 4, do we put a bracket or a parenthesis?
Bracket.
At 4, at that moment in time when the stick figure's standing there, is he walking uphill?
No.
No.
So parentheses.
So parenthesis because we don't include it. Okay. And then for decreasing, what should we put?
Infinity 4.
Now we have to go from smaller to bigger. 4 infinity, good. Okay, and then at 4, bracket or parenthesis.
Bracket because you're included.
Now if he stands there, if he stands there, is he actively going downhill? No, he's standing at the top. Parenthesis. Okay. Increasing, decreasing, max min.
The maximum is the vertex, right?
Yep. So maximum is the vertex, so that's 4, 3. What should I write for minimum?
Negative 3.
Wait.
Infinity.
Nope. Because those aren't real numbers.
Yeah.
Nope.
None.
So you only have one or the other, you don't have both. Arrows don't count as real points that we can actually like say, yeah, that's a point on the graph, I can put my finger on that. So the vertex, that's a real point, that's a real maximum. If there's a maximum, there's no minimum for these graphs. So when you find a max or a max looks like a mountaintop, a min looks like a valley. And if you don't have one of those, then it's just not there. So mountaintop or a valley. Okay. Intercepts. We need an x-intercept. Well, 2 x-intercepts. We need a y-intercept. We remember how to find those on the calculator?
Vaguely.
Yeah? Okay, so we're going to have to graph this. Oh, where the buttons are like scratched off. So we're going to type a -2. Have you already typed the equation?
No,
So to type the equation, you have to go to the y equals button first.
how do I get here? How do I get there?
The y equals button.
How do you get rid of the random on the calculator? It's like second.
Second plus 712.
How did you get to which button was it? That?
Y equals.
I'm lost. I don't know where the y equals button is.
The very top left.
So do I just press that?
Yep. Mm-hmm.
And then press graph.
Mm-hmm. Did you finish typing it in?
Yeah.
Okay. Yeah, once you have it typed, you can go ahead and press graph, and then it should look the same as what we drew.
And then press second trace 0.
Uh-huh. Second trace number
Right.
2, which is zeros.
When I hit graph, it gave me like quit or go to.
So my guess is what you did is you messed up your minuses. So remember, this is a negative, so that's the one that's underneath the 3. And this is a minus, and that's the one that's right next to the 6. So one should be short and one should be long.
Yeah, that's what I did.
Yeah. See how I read your mind? Man, Miss Rice, you're impressive. I know, Miss Rice. Thank you. No? Okay. I thought it was good. All right. So the first x-intercept looks like it's near the 3. I'm going to look for it between 2 and 4. So I'm going to say second trace, option number 2. Mm-hmm. And I'm gonna look between 2 and 4. I'm not so sure. It looks like it's to the right of 3, but I'm not positive. So I'm gonna use 2 for the left bound. If you already typed 3, you're probably fine. So I'm gonna use 2 for the left bound, and I'm gonna use 4 for the right bound. And then it says guess, and the guess is always stupid. 2. Yeah, if you use 3, it wouldn't have worked. You have to use 2, because 3 is too far.
Just figured that out.
Yeah. Did you do your left bound, right bound? It should be 775, 2.775. Okay. And then the next one, between 4 and 6,
Where do I write this down?
just on the paper somewhere. 5.225.
Do I have to worry about where like the little cursor thing is?
Nope.
Okay.
Some people prefer to move their cursor to the left bound and right bound and do it that way, but I think it's easier to plug in numbers.
What is my next left bound?
So if the number's right here, then I would do like 4 to 6, or you could do 4 to 10. Just anything that's to the left and right of this x-intercept.
So did you guys get 5.224 or 225?
Mm-hmm. Yeah. And then for the y-intercept, we do second trace number 1, and we plug in x equals, what do we plug in for x to find the y-intercept? It's always the same, not 1, 0. So 0, negative 29. Okay, is the graph continuous? Can you trace it with your finger without picking up your finger?
Yes.
Yes. Okay. So continuous. Yes. And now we have to describe the arrows. So what do the arrows do? Left arrow goes down, right arrow goes down. Okay, so I'm going to say, as I look at the left arrow, it goes down. So I'm going to say y goes to negative infinity. So left arrow goes down. As I look at the right arrow
goes to negative infinity.
negative infinity as well.
So, for that, could you look at negative infinity is left and infinity is right?
Yeah, so an x negative infinity is left, an x positive infinity is right, a y negative infinity is down, a y positive infinity is up.
Okay.
Mm-hmm.
So the y's are always going to be the same, unless it's
Yeah, they're either both going to be up or both going to be down. And it always starts like this. X to negative infinity, x to positive infinity, because you're always looking to the left and looking to the right. Left arrow, right arrow. Yeah. If we were to graph this one and not do it by hand, 3 times x plus 0 squared minus 8. I'm just going to put a 0 in there so we can find our vertex easily. What would the vertex be?
The vertex
Mhm.
would be
0, negative 8. So 0, negative 8. So there's the vertex. So what I would do is I would graph this, and then on the table I would look for that vertex. So I'm going to go ahead and hit y equals. You can type it in with the 0 or without the 0. It doesn't matter. So 3x squared minus 8. Or you can do the parenthesis version with the 0. It's fine either way. And I would graph it. I'm going to ignore the picture for now. I'm going to just look at the table. And what I would do is I would get that vertex right in the middle. And then I would say, okay, this is the middle of the graph. I would graph a couple points this way and a couple points that way. And then that gives me the whole picture. That's on my calculator. Now, if I ever take your calculator away on a test, you can graph it by hand.
So if I just do that for every single one, do I have to handwrite out?
No, no. Now, the reason I teach you guys how to do it by hand is because you guys are taking honors math 3, and should you ever choose to continue to do math, they start to take your calculators away. And I want you guys to understand the math well enough that you could always do it by hand. So that's why I teach it to you. But it's also a good tool to know how to do it in a calculator and graph the important parts that you need. So this is the middle of the graph. 0, negative 8 is the middle. And so then the other points, negative 1, negative 5, positive 1, negative 5, negative 2, 4. This one is super stretched out because it has the 3 in front of it, so it's like super tall and skinny. But this is a valid way of graphing it too if it's a calculator active test. And unless I tell you that you have to show your work on graphing it, which I don't, unless I tell you you have to show your work on graphing it, you could graph it this way.
What button do you hit to get to the table flip?
You hit second graph. Yeah. And you can always remember that because it says above the graph button, it says table in blue.
It's from 3 to 4, right? Or it's maybe from-
It goes till 4, but I don't mind staying and answering more questions if you guys
Well,
want.
it's just not till my band direction.
Oh, yeah. No, that's fine. That's fine.
Thank you.
Yeah, no problem. Is there another one you wanted to look at?
I am just trying, I'm blanking.
Mhm.
I'm having brain fart, and I'm just looking for my, vertex formulas.
Mm.
I know that. Yeah. So, this is like the adjunct to the side,
Mhm.
by the, okay. Do I need to use like the X thing?
The X thingy that you're talking about, so this is converting into vertex form by completing the square. The X thingy that you're talking about is completely different. That's with factoring, and that's actually what we would do on number 1. So number 1, you'd look and you'd say, oh, what multiplies to 36 but adds to 12? That's factoring. And you'd also do that with problem number 3. Problem number 3 is a slide divide problem. You'd say, okay, look at the 2. That 2 is not a GCF. So I'm going to go ahead and take the 2 and slide it over to the negative 81. So 2 times negative 81 is negative 162. So I'm looking for something that multiplies to negative 162 but adds to 9. So that's what you're talking about, the little X thing, that's factoring.
Okay.
And these are the ones where your final answer has 2 sets of parentheses.
Oh, so it's like the,
Yeah, that's the factoring stuff.
So answer number 1 would be x plus 6, x plus 6.
Mm-hmm.
Put it right as x plus 6 squared.
You can write it as x plus 6 squared, yep.
Thank God, because that's hard with it.
Yep.
And then what about
So, yeah, so if you're having a hard time finding the numbers that do that, this is where we could take our... You can't do the quadratic formula because there's no equal sign. Oh, you did the completing the square? So that won't, it will get, you can solve an answer that way if there's an equal sign, but you can't factor that way. So, but the calculator can help you with this. We could take the calculator and do negative 162 divided by x, and then we can look at our table and it will tell us the options that we have that add to 9. Yeah. So negative 162 divided by x. And then if you hit second graph, now these are all the options that multiply to what we want them to multiply, and we just have to find the one that adds to 9. So negative 1 and 162, that adds to 161, that's way too big. Negative 2 and 81, that adds to 79, that's way too big. Yeah. 18, negative 9. Okay, so we're going to say a and 18, a and negative 9. So then we go and we say, okay, we took a 2 and we slid it over. We're not done yet. We take the number that we slid and we divide by that number. And if you can divide evenly, you do. So over here, where 18 divided by 2, that divides evenly, right?
So that's
8 plus 9, uh-huh.
8 minus 4.
Yeah, now over on this one, if 9 over 2 can be reduced, you would reduce it. But 9 over 2 doesn't reduce. It would just stay 9 over 2. And so what you do over here is you take the bottom of the fraction and you move it to the front of the variable. So 2a minus 9. And then that's your answer. And that's the method that I call slide divide bottoms up. And some people prefer the box method, so if you like that better, you could do that, or if you like guess and check. Yeah, so if you had done this problem with the box method, you would have put the 2a squared here, you would have put the negative 81 here, and then when you were doing it and you got the 18 and the negative 9, you would have put those in these two boxes, and it doesn't matter which one's which. So you would have put 18 with an A. 1A, 1A, or 1A and 2A? So, and then from here, yeah, and then from here you take out the GCF. So you'd say between 2 and 18, you have a GCF of 2. Between a squared and a, you have a GCF of a. Between negative 9 and negative 81, you have a GCF of negative 9. And then across here, between 2 and negative 9, there's no GCF. Between a squared and a, there's a GCF of a. Between 18 and 81, there's a GCF of 9. And then between the a, there's no GCF. And so then you would have said, oh, my factors are 2a minus 9 and a plus 9. So it's the same thing. It's just like mentally, it's a different way of thinking about it, and it just kind of depends what your brain feels good about. Yeah. So this is kind of like a multiplication table, and some people like that better, but it's up to you.
We want to go through the number 10, which is one of the factors we just
Wait, number 10. Yeah. Okay. So.
A squared minus 12a plus 7 equals 0.
Okay. So. Wait, minus 12a?
Yeah, minus.
Okay. So they said in the directions to try to factor it if you could, and if you can't factor it, then to use the quadratic formula. That's what the directions said. So this, if we could factor it, this would be a slide divide problem. Well, I'll show you. So you do 8 times 7. We start with slide divide. 8 times 7 is 56. So we'd say, okay, multiply to 56, add to negative 12. And I would grab my calculator and do this thing again. So 56 divided by x. So I'm going to look through the list and I'm going to see if anything multiplies to 56 that adds to negative 12. And when I look through the list, what's going to happen is I'm not going to find anything. So I can see that these two, negative 8 and negative 7, those add to negative 15. Yeah, negative 4 and negative 14 add to negative 18. And then these add to negative 30, add to negative 57. But there was nothing, I can go the opposite direction, but there's nothing adds to negative 18. There was nothing that added to negative 12. It just wouldn't work. And so that tells me, okay, this is not factorable. I have to do the quadratic formula. So then we'll go ahead and go through the process for that. Let me go ahead and write it up here. So since our b is a negative 12, then I've got the negative of negative b, right? Negative of negative 12, plus or minus.
So why don't I just write 12?
You could do that. Yeah. I think I don't like to do that because then I forget if I change my sign or not. So I like to just write it. Then we got b squared minus 4 times a times c, all divided by 2a. So 12 in the front, 16 on the bottom. So now I'm going to type in I'm not typing in the square root sign, I'm just typing in the stuff underneath the square root sign. And the reason I do that is because if the stuff underneath the square root sign is negative, and I type all of it in, then my calculator is going to give me an error and I'm going to get frustrated. Mm-hmm. Mm-hmm. Okay, so we're going to write negative 80. And then since the number and the square root was a negative, we're going to take that, we're going to make it positive and stick an I in front of the square root, and then we're done, because that's imaginary.
So not factorable at all.
Yeah, with that one we just stop, yeah.
Which one can be factored?
I know one of them is factorable, I just don't remember which one. Oh, I can do it from my computer. Here, let's see. Number 12 factors and number 15 factors. Which one would you rather do? Number 12 factors in a way where it's really similar. It's similar to number 3. And number 15 is similar to number 4.
Let's do
Both? Okay.
that. That's okay.
Yeah, that's fine.
Am I keeping you wrong?
Huh?
Am I keeping you wrong?
No, you're fine. Okay. So we will go ahead and move the x squared and the 3 because we want it to equal 0, right? So we can start with that. Okay. And so then we say, okay, this is a 5. It's not a GCF. I can't take it out. And so that means this is a slide divide problem. So I'm going to do 5 multiplied by 4 is 20. So I'm looking for what multiplies to 20 but adds to negative 12. So you're doing 20 divided by x, and then looking at the table. So we're going to look at the negatives, right? Because we're adding to a negative 12, so we should be looking at the negatives.
Okay, so 20 divided by x, correct?
Uh-huh. So if
Second
these,
table.
uh-huh. So if these are my options, is this what you see up here?
Yes, it's made 30.
So if we look at the first one, negative 1 and negative 20, that adds to negative 21, so that can't be it. What about negative 2 and negative 10?
Where'd you get the negative from?
I scrolled up. So I started with this,
Oh, yeah, I would. Oh.
and then I scrolled because I knew I needed the negative answers. Mm-hmm. So in the parentheses, x minus 2, x minus 10. So we slid the 5 to the 4. Now what do we do with the 5? Divided by 5. So this one doesn't simplify, right?
Yes, I do 5.
5x minus 2. What about the other one? X minus... What did you say for this one? 2. Mm-hmm. Okay. And then now we can go ahead and write our 2 answers. Do you remember how factors give you answers? One of these is going to be a fraction. One of these is going to be a whole number. And they give you answers that are opposite signs of what is in the parentheses. So if this said x minus 2, the answer is 2, just positive 2. And then this one over here, you can kind of see the answer up here a little bit better. The answer is positive 2/5. So positive 2 over 5. Okay. So 15. This is not the x because there's only two terms.
Okay, so it's the square.
So it looks like the square because it's got a 25, but then it's got a 5, which is not a square.
So
And it's a plus, not a minus, so it's a GCF. So what can we take out? What's the GCF that we could take out that divides into both of them? 5. What about the variables? N, okay. So we're going to take out a 5n. And for the first term, if you take out a 5n, what's left over? There's something, because this is an n and that's an n squared. N, okay. And for 25n, if you divide out 5n, what's left over? Okay. So again, we get two answers. We get one answer for this n in the front and one answer for this n in the parentheses. So this one's the easiest. What's the one in the parentheses? Well, it's not a fraction. You're close. -5, because it's the opposite sign. Okay. And then the one in the front is a little bit weird, so I'm going to remind you of like how we find them. So the way that we would have found this one if we did it by hand is we would say, okay, n plus 5 equals 0, and then I'm solving it. And then I would have minused the 5 from both sides, and n equals -5. That's how you would actually solve it by hand. And so with the one in the front, we might have to actually solve it by hand to figure out what the answer is.
So it's n equals
It's not that. 5n equals 0. 5 times n equals 0. So how do you do multiply?
So it's
What's 0 divided by 5? 0.
0. So it's n equals 0.
Yeah, anytime you have an n in the front like that, that n is always 0. So it could be an n in the front, it could be an n squared in the front, it could be an n cubed in the front, and it could be by itself or it could have a number, but anytime it's sitting in the front like that, it's a 0.
That's it.
Okay.